Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, let us solve the next question. Question number 7 of NEET Physics 2014. Friends, let us solve the next question, which is number 7. It talks about a body of mass 4m is lying on xy plane at rest. So, there is a body of mass 4m lying on this xy plane. Suppose this is my xy plane and it is at rest. So, rest, there is no momentum. It suddenly explodes into 3 pieces. 2 pieces each of mass m. So, this explodes into 3 pieces. This seems like a mass, but it is 0 velocity. Okay, I will consider this as one mass. And 2 equal masses m. So let us say this is m, this is m, move perpendicular to each other with equal speed. Suppose this moves with the velocity v, this moves with the velocity v in the direction perpendicular to this. Then the total kinetic energy generated due to explosion is. So the thing is that out of this 4m, only 2m is here. The other 2m must be moving. Other 2m must be moving, so that the momentum due to this 2 will be equal to this, and in opposite direction. So that will cancel out and gives you 0, because initially it was 0 momentum. So applying conservation of linear momentum principle, that in the absence of net external force, the momentum of the system will remain same. Here, the momentum of one particle, which was 0 initially, and it explodes because of internal forces, not external forces. So, momentum will be conserved. If it breaks into 3 parts, m, 2 masses, and 2m, the m, 2 masses, and 2m, the other one, then whatever be their momentum, collectively it gives you 0, because initially it was 0. I know the momentum of 2 particles in perpendicular directions, so the net momentum I find out in this direction. Suppose the net momentum is in this direction, the third particle having mass 2m must be moving in the opposite direction, so that these 2 vectors will cancel out and that will give you 0. Therefore, let us find the momentum due to these 2 particles. If I choose this as the origin itself, that the particle was lying in the origin for the sake of convenience, this is moving in this direction, this is moving in that direction. We are interested in the magnitude, because I know that the resultant of this momentum will be in this direction, and these 2 and this one must be in the opposite direction and having the same momentum. I don't know the momentum of this second mass. So I'll first find, suppose that the velocity of this move is v dash. So I have the momentum 2m v dash. From here I can find out the total momentum, and this becomes equal to this, so I can find v dash. When I get to v dash, then I go to kinetic energy. So kinetic energy is sum of energy possessed by this and this. So all the 3 particles kinetic energy have to be added up. So if I call this P1, I call this momentum P2 and call this momentum P3, then obviously the sum of all these 3 momentum must be 0, because initially it was 0. So that must match. I'm talking about P1 and P2, these 2 vectors So in magnitude wise, P3 must be equal to P1 plus P2. And direction wise, it is opposite. We are not interested in direction because our aim is to deal with kinetic energy, which is a scalar quantity. So just I want the speed with which it will move. That is sufficient to solve the question. P1 plus P2, that is the vector sum of these two. If these two vectors are perpendicular and having same mass, same velocity, we know that it will be root 2 times mv. How come? That I will explain to you. But this you should remember and always use it. When the angle is two vectors are similar, same magnitude, but if they are perpendicular to each other, then the resultant will be root 2 times the individual one. That means because momentum are same, P2, P1 is also mass into V, and this vector is P2, which is also m into V. These two vectors are same in magnitude, but the angle is 90 degree. We use the parallelogram law of vector addition because they are vectors, but they are added with the law of vector addition, and this is the resultant. That is the sum of P1 plus P2 vector. It will come out to be root 2 times the individual one that I have written, but how it is done? Because I write the resultant momentum will be of these two combinations will be P1 square plus P2 square plus 2 P1 P2 cos of theta under root. This is the formula we generally use. Now you can put these values over here. P square, suppose this is P, I drop 1 and 2 because they're same. P square, 2, P square, theta being 90, it is 0. So this part is 0 and this is 2P square root, which comes out to be root 2 times P. P is mv, so it will be root 2 times m into V. I just told you earlier because this is what you should remember to save time. If the angle between two vectors is 90 and they are same vectors A and A, then the resultant will be root 2 times A. If the angle between two vectors is 60 and they are same vectors, magnitude is same, then it will be root 3 times A. So these are things that will save your time. So I got root 2 MA. After I got root 2 MA, I move to the first one, that this is root 2 MV. Root 2 MV. So this must be equal to this momentum in terms of magnitude, and direction is exactly opposite. I don't need this, must be 45 degree. This will be 45 degree. This will also be 45 degree with respect to the x-axis or y-axis. Symmetrical position. Momentum of P3 comes out to be 2mv dash, must match with this one, so that they will cancel and it gives you 0. Root 2mv must be equal to 2mv dash. So 2mv dash is root 2 m into v. M will cancel out. V dash is v upon root of 2 because this is 2 here, coming down here, and root 2 is left, this will go. Now what? Now the problem is solved. We have 3 particles, mass m, moving v. Okay. Another particle is there, mass m, moving v, perpendicular. Direction is not important because 2m is moving with v dash, which was v upon root 2. The energy possessed by this particle, kinetic energy of this particle is suppose k1, kinetic energy of this particle is suppose k2, and kinetic energy of this particle is suppose k3. The total kinetic energy of the system. Total kinetic energy generated due to explosions. So the total kinetic energy must be sum of all 3. So total kinetic energy is equal to sum of the individual kinetic energy. This is half of mv square plus this also half of mv square, that is the formula for kinetic energy, half mv square plus half of m is to m here, v square is square of this, so it is becoming v square upon 2. So I'll cancel 1, 2. You can see that this is half mv square, this is half mv square, this is also half mv square. So this becomes 3 upon 2 mv square. This is the total kinetic energy of the system. So half mv square, half mv square, and half mv square. This is half m. One cancels, so square of this is v square by 2. Half m. Half m v square by 2. So 2 is left. So this is 1, 2, 3. 3 by 2 is mv square. So the total kinetic energy comes out to be 3 by 2 mv square. If you see the options, 3 by 2 mv square is there is a mistake over here. It should be, it is not this. It should be 3 by 2. It should be 3 by 2 mv square. So this option is correct. So there is a mistake over here. So this is the answer to this question. So it was a combination of application of conservation of momentum, and then you find the kinetic energy generated by that explosion. Okay, thank you.